Okay, you guys, welcome to Chapter 5A. We're going to start in 5.1 talking about perpendicular and angle bisectors. Before we get started, I just wanted to talk to you about what the word equidistant means. And you can kind of guess just by looking at it. Equidistant is a point that's the same distance, equal distance, the same distance from two or more objects. So right off the bat, we're going to talk about how distance and perpendicular bisectors are related to each other. And of course we have theorems. The first theorem is the perpendicular bisector theorem. The second, the converse. Go figure, right? The converse of the perpendicular bisector theorem. So if we talk about just the regular old perpendicular bisector theorem here, it reads, if a point is on a perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So that's saying, let's say I've got point X here. X is on the perpendicular bisector for AB. What happens is, it's equidistant then from the endpoints of the segment. So they're telling you right now that XA has to be congruent to XB. It's got to be equidistant to the endpoints here. The converse then flips the hypothesis and the conclusion, It says if a point's equidistant from the endpoints, now it goes backwards. So if X is actual equidistant from A and B, what happens is it's now sitting on the perpendicular bisector. So you just proved that this is going to be the perpendicular bisector. So it's perpendicular and it bisects. All right, so using this information, we're going to go ahead and solve for missing pieces here. I'll do the first one, then I'm going to have you guys work on the second one, then we're going to see what happens, okay? So, if you take a look, I want you to find the measure of the following, and in this case, we want to find MN. So what's going to happen is I want you to think about this proof-wise. What do we know? Well, we know, sorry for my handwriting, it's been a while since I've done this. We know from the picture that NL has to be congruent to NM. So NL has to be congruent to NM. And the reason why, you guys, because of what we just learned, the perpendicular bisector theorem. Okay, therefore, if NL is 2.6, then if they're congruent, their measures are equal, you guys, and NM, or MN, sorry, has to equal 2.6 as well. So following suit, I want you guys to pause me and go ahead and do part B. All right, part B, you were looking for BC, okay? So you should know, I'm going to write this out the way I did before, we know BD has to be congruent to CD, and this was because of, now not because of the perpendicular bisector theorem, but the converse of the perpendicular bisector theorem. Okay, so therefore, if CD is 12, then BD has to equal 12. So BC should equal, oh, that's not a B. BC should equal the 12 plus the 12 because it's the two combined, right? So we should get 24. All right, part C, I would like for you to please find TU. Pause me, work on it by yourself, and then find TU, please, and then hit play. All right, so following suit from before, you guys, because of our perpendicular bisector theorem, we should know that TU has to be congruent to UV, right? Perpendicular bisector, so these two have to be congruent. So if they're congruent, we should know that their measures are equal. So I could take 3x plus 9 equals 7x minus 17. And when you solve, let's see here, 26 equals 4x. You should have gotten that x is about 6.5. But that's not what we're looking for, you guys. We're not looking for x, we're looking for TU, remember? So all you have to do is plug it in now. So 3 times 6.5 plus 9 gives you that TU is 28.5. Okay, so what kind of notes would it be if we didn't have more theorems, right, you guys? So still talking about distance and bisectors, but now it's going to be angle bisectors here. Last time we were talking about perpendicular bisectors. So the first one is the angle bisector theorem, and then of course we got to go backwards with the converse of the angle bisector theorem. So I'm going to change colors here, you guys. Let's do something cool like green. All right, so first off, the angle bisector theorem says if a point is on the bisector of an angle, so I got angle APB here, here's my bisector, right? Leaving C to be the point. If the point is on the bisector of an angle, in this case we got point C, then it's equidistant. It's equal distances from the sides of the triangle. So if this happens, it's got to be equal distance. So AC has to be congruent or equal to BC. Now going backwards, all right, it says if a point in the interior of an angle is equidistant from the sides, so we're still talking about C, if you see a point in the interior and you see that it's equidistant from those sides, then this point has to be on the angle bisector. So that's going to make these two angles congruent. So let's try it, you guys. Find the measure of BC. Find the measure of BC. So now I want you to think about this proof-wise, right? So like we did before, we know, what do we know? Well, we should know that BC has to be congruent to DC. BC has to be congruent to DC. The reason why, well, it's a point on the angle bisector. So this is because, we know this, because of our angle bisector theorem. Okay, so if DC is 7.2, well, BC has to be 7.2. I want you to talk it through just like this, you guys. It's going to help you out in the long run. Okay, I want you guys to try this one and then hit play again and then we'll go over this. Okay, so what you should have done, remember our thought process. We know, what do we know? Well, looking at the picture here, we know that angle EFH has to be congruent to angle GFH, and this is because of the converse of the angle bisector theorem. So this is the converse of the angle bisector theorem. Okay, so then, right, if measure of angle EFG is 50 degrees, if this is a bisector and I want to know what EFH is, all you have to do is take half of 50. So the measure of angle EFH has to be 25 degrees. Okay, following just like we did before, throwing in some variables here, I want you guys to find the measure of angle MKL and then come on back and we'll go over it. Okay, so you should say, we know. What do you guys know? Well, you know that angle JKM has to be congruent to angle LKM, and this is because of the converse of the angle bisector theorem. Okay, identifying this is important, you guys. So now that we know it's the converse of the angle bisector theorem, we should know that these two have to be congruent. And if they're congruent, their measures are equal. So 3a plus 20 should equal 2a plus 26. You guys should have gotten that a is 6. But again, we're not done. We need MKL. So if I plug it in, the measure of angle KL, what is this? 2 times 6 plus 26. You guys should have gotten 38 degrees. All right, it's everybody's favorite, the word problems. Woohoo! All right, so let's read it. John wants to hang a spotlight along the back of a display case. It tells you that AD and CD are the same length, so I'm going to mark them congruent here. It also says that A and C are equidistant from B, so that also makes this congruent here. The question is, how do the wires keep the spotlight centered? Well, let's talk about this. And I'm going to write this out for you guys so you can hear it and you can see it. Since we know, so let's see here, what do we have here? Since we know that AD is congruent to DC, you should also know, because of this, that DB is the, perpendicular bisector of AC. Okay, so since those are congruent, you should know that DB is the perpendicular bisector of AC. All right? We also know that B is the midpoint of AC, right? We know that because these two lengths are congruent here. So, BD is the perpendicular bisector of AC there as well, so both cases. So D has got to be centered below B. Okay, that means that both of these are in the same position. So D is centered below B. Okay? So, let's think about this. We know now that the wires keep it centered because the congruent sides make them perpendicular to each other. And if it's perpendicular, we're not moving anywhere. If they're centered, they're centered. So the wires, let me go back to green. The wires keep the light centered because the congruent sides make BD perpendicular to AC. Okay, in both cases, this was the part that we really needed. We needed to know that they were centered below. Okay, so these being suspense lines, you guys should kind of sort of have an idea that they've got to be congruent to each other. Otherwise, this guy is going to be twirling around and round and round and round, right? So, PQ has to be congruent to QR. Okay, therefore, remember those three dots mean therefore. Therefore, Q, what do we know about Q? Q has to be on the perpendicular bisector of PR. And this is because the converse of the perpendicular bisector theorem. Right? So those are congruent, so therefore Q has to be on there because of the perpendicular bisector theorem. Sorry, the converse of that. So the information that we have, S is equidistant from those. So since S is the midpoint of PR, QS has to be the perpendicular bisector of PR. So long story short, what can I conclude about QS? Well, QS is a perpendicular bisector, so it's perpendicular to PR and it bisects it. Okay? So, lots of crazy information here, you guys. You have to know the theorems, and you have to be able to apply them. I need you to get used to talking yourself through this. I need you to get used to taking a look at the picture and seeing what do you know. Okay? All right, we'll talk more about this when we see you next. Have a great night, you guys.